Hi everyone, Mr. Masterson here. Here to talk to you about physical and chemical change. Typically, physical change is a little easier to understand, and chemical change is a little tougher because the substance is actually going from what you once knew it as into something else, and sometimes that something else is something you can't see. But either way, when you have a physical or chemical change, you don't lose the mass, you don't lose the energy, and this is called conservation of mass, conservation of energy. And oftentimes in nature, nothing remains stable for a long period of time. It's always changing the state that it's in. For example, water can go from ice to a gas. A rock is still a rock if you break it in half. That would be a physical change. But if you melt it down, maybe you get iron out of iron ore. Some of that mass is going to be lost to the atmosphere as heat and smoke. But then the atmosphere has gained the mass. So let me show you some examples of physical change and chemical change. Okay. So here we have on my desk, I have some materials here for our demo today. I have acetone, which is the same thing that's a nail polish remover. Super toxic chemical. Don't want to really be using acetone on your nails. Maybe you find something that's a little bit less caustic or less harmful. Certainly bad to pour down the drain as well. Have a styrofoam ball. Have a beaker here. Okay. Have what's known as a crucible. This can handle any type of high temperature liquid metal or chemical. We have lead, which is a really malleable metal. It's an element on the periodic table under the letters Pb. I think that's where the word plumber comes from, because they use lead all the times when they solder pipes together. It is a metal that can cause some problems health-wise, so you don't want to chew on it, eat it. It's used for fishing waste, but they're trying to do away with that as well, because when it's left behind in the ocean and ponds, animals can eat this and get sick. Okay, so let's see, what else do I have here? A little lighter piece of paper. So here's an example of physical change, right? I take this piece of paper and I rip it in half. Physically, it has changed. It's gone from a one large piece of paper to two smaller pieces. I can further change this chemically by taking it and lighting it on fire. So what happens is the paper's gone from a white color to this black ash, which produced light and heat and smoke. Okay? Now, if we captured all this stuff in a closed environment, the mass of that paper wouldn't have changed. But it's an open environment. Incidentally, where did the paper come from? It came from a tree. So that tree went through a physical change as well. It was broken down, changed into pulp, and made into paper. So this is a basic example of physical and chemical change. Let's take this styrofoam, do the same sort of thing. You may have seen this before, where you take styrofoam and you can put some acetone on it and get a physical and chemical change that way. So here's my physical change. I took that styrofoam ball, cut it in half. Now I have two small ones. So physically it's changed. Can we glue it back together? Yup. Would it be the same shape and all that? Sure thing. So a physical change means you're changing something, but it could be put back together. That's a good way to remember it. Let's take a look at what happens when we put a little acetone on there. So here's my beaker with the styrofoam in there. I'll add a little acetone to it. And let's take a look at the reaction of the styrofoam. You can see in here, hopefully you can see in here on the camera. I'll move the camera to the styrofoam. But what we have is no more styrofoam. And if you didn't see it, we'll add another one. So now we have a cloudy sort of acetone. But the acetone likes to eat away the styrofoam. So if you are using acetone at home, you definitely don't want to be using it in a holder that's made of styrofoam or plastic, because that will get eaten up. Okay? So there's your physical and chemical change for styrofoam. Let's take a look at this one. Here we have propane. Okay? Propane is a gas that's used to heat your home or to maybe ignite the flame on your stove. So it's stored in this container under pressure, and it's stored in the form of potential energy. So if we take a lighter and we let some of the gas escape, we can get a flame from it. Okay, so let's take this flame. We have it now. We have a physical change. We have the flame that's coming out of there turning into a gas, and this gas now can be applied to the lead. And if you can see what's happening to the lead is going through a physical and chemical change. It's melting. It's melting and dropping into the crucible, and we have lead that was once solid, now a liquid, and then when it cools off, it'll return back into a solid again. So let me turn the gas off. Okay, so again, the propane here went through a chemical change. It went from this liquid state, you could shake it and feel it in there, then it turns into a gas, and this gas, when ignited, produces a lot of heat and light as well. If it was dark, you'd see light. So if we can look now inside our crucible at the lead, you can see that the once liquid lead has now resolidified back into metal again. And these, like, looks like a frozen water droplet. So the lead, can be shaped easily. It can be made into fishing lures and fishing weights and all that sort of thing. So it's very common for that. So that's physical and chemical change. Maybe we'll do one more conservation of mass example after this.